I'm Debbie, and I lead developer experience at Lit Protocol. And today, I'm going to go over a bit of our SDK v3, as well as how you can find resources to build. And I do want to say we're really excited to see what projects you're building. And for the Lit specific prizes, we are only giving out for folks building on Lit's newest SDK, which is in beta, which you can see from our docs on that top header banner. And so jumping into it, what is Lit? Lit, from even just this overview section here, you can see it says Lit Protocol lets you create and manage distributed cryptographic key pairs for condition-based encryption and programmatic signing. A decentralized key management network. Lit can be used in place of centralized key custodians and other key management solutions. So what does that actually mean? Some of the core use cases of a Lit are decentralized access control, where you're able to set access control and then encrypt content, where based on those access control conditions, someone can decrypt that content. Or on that programmatic signing piece, you're able to set some conditions saying, okay, I want to be able to sign, or I want someone else to sign on my behalf if these conditions are met. So being able to use Lit's network to be able to do that. And that's through what we'll call programmatic signing, or through our programmable key pairs and Lit actions. If you want to learn more about that, you can see within the docs page here, the decentralized access control. So just a higher level concept view of what you can build with Lit in terms of decentralized access, as well as on that programmatic side, being able to set up account abstraction and then one of our newest features, which I'm really, really excited for folks to build with, we do call it claimable keys, which is essentially you're able to deterministically derive keys so that the public portion of the key pair is known before creating the full key pair. So a use case with that is you might want to create and seed a wallet for someone with some amount of asset. Let's say you want to put like 0.1 Matic, or you want to put like the Lit testnet token in there. You're able to kind of get they're able to come onto your platform, input their auth type, so that might be email, that might be SMS, and then be able to generate a claimable key. And then after that generation process, they're able to come back onto the platform and then claim that wallet. So the claiming process would be associating their auth with this public key pair, and then on the Lit network side, fully connecting that through, saying, okay, this person now has ownership over this key. They have now claimed it. It is theirs. As well as programmable signing, so setting conditional signing automations, as well as being able to set up MPC wallets, where a programmable key pair is essentially an MPC wallet. And the MPC part is utilizing Lit's network, which is a multi-party computation network. And then a public-private key pair is the wallet component. So how you would utilize Lit, let's go into this installation side. So right now, our v3 is in beta. So be sure to, when you're importing it, either this is a general import or on server side through the Node.js, you're actually doing this tagged where you're doing version 3. I think now it's actually not just 2, it's 5, 3.0.5 or above. On the server side, you'd be importing the Lit Node client Node.js package. And so one thing to note is for general purpose use, I think Lit Node client will fit most use cases. We do have a mono repo for our SDKs, so a lot of times, like if you need something a bit more complicated or you need something more custom, please go into GitHub, as well as, let me pull up actually our JS SDK API documentation for y'all so you can see what this layout is. So we have these modules where we have the JS SDK, and underneath that we have the access control conditions package, auth browser, auth helpers, BLS SDK, core, crypto. So if you have more unique or advanced use cases, be sure to look through here to see what you need to include in your project. So with the installation, you'll import the 3.0 package or above, and then make sure that when you're connecting to the lit node client that you're passing in the lit network as cayenne. For v3, that is the only network that is supported, and so make sure that that flag is added in. And then for we have different helpers on how do you authenticate through lit, either through authsig or through session signatures. Be sure to read these part of the docs on getting that set up, depending on what your use case is. And then for access control, I actually want to walk you all through a demo or a code repo that I made for using access control, where if you've been with lit since SDK v1, SDK v2, and now we're on SDK v3. If you've been with us for v1 or v2, we have changed how encryption works. So encryption now is what we call ID encrypt, and the usage of it is a little bit different, where we don't have symmetric keys anymore. We have a different way of interacting with the nodes, so there are different calls. So let's actually jump into an example. And this will all be linked in off of Lit's page on ETHGlobal site for ETHOnline, so be sure to check that out as you're going along with this video. So you can go into my GitHub, which I'm Debly, and then to get here, go to my GitHub Debly. You can find this on my homepage, ipfs-lit, and make sure that you're actually on the SDK lit SDK v3 branch. So we're on the SDK v3 branch, where this example has the most up-to-date usage of ID encrypt. And so from here, some basics is you'll need to set up a project with Infura, where you'll need your project ID and project secret, as well as making sure you're importing the lit node client version 3.0.1 or above. And then within the setup page, where you can find this within actually the lit.ts or JS file, is setting up how do we use lit, and setting up, making sure the network's cayenne, and then connecting the lit node client, which is necessary for interacting with the lit nodes in general. So having this async and await is really important here, so don't forget that. And then in this example, we just do like a fraction of 1 ETH as the access control condition. And what the encryption looks like with ID encrypt is we get an authsig, and then we call encrypt string with that data to encrypt. And in this example, it's a URL string passing the chain Ethereum. We have that auth signature that we generated previously, as well as our access control condition, which is just that fraction of a ETH. And so what gets passed back is this encrypted object. So for lit.encrypt string, it'll pass back a ciphertext and a data to encrypt hash. So just like the encrypted hash, as well as the symmetric key from V2 version of using the lit SDK, you also need to save both of them because you'll need both to decrypt. And then for a decryption function of string, it's pretty straightforward. You need to pass in access control conditions, ciphertext, which is what we've received from that encryption step, as well as that data to encrypt hash we received previously, and then an auth signature chain, which in this example is Ethereum, and then also pass in the lit node client. Why we pass in the lit node client is just this function is a bit more closer to functional programming, where you also do pass in that function or object, so make sure to include that, which is just a lit node client we've initiated for using in this project. Yeah, and then that's pretty straightforward. And so from this example, you should be able to encrypt and upload to IPFS, and then when you're decrypting, you should be able to see that file on display on this site. And if you want to check out more examples, we have another example that's actually within the lit.js SDK branch v3, and this is another example of just doing a simple encrypt and decrypt of just a string, where you could change the string and you can see based on the input on the left-hand side, kind of the code and output on the right-hand side. Yeah, so excited for y'all to use ID Encrypt. It is significantly faster than our previous encryption on Serrano and Jalapeno, which are also the older testnets. And so encryption and decryption now should take about 2 milliseconds, whereas before it took up to 100 milliseconds. And so this is a really big improvement on, just like speed and like node interactivity. If you want to do different types of access control conditions, be sure to check out types of conditions, as well as certain, like more specifically for EVM or other chains. It's all documented here. And then if you still have questions, please go on Discord and ask us there. And then before I jump into claimable keys, I'm going to actually talk a little bit about programmable wallets. So programmable wallets are MPC wallets that can that have an additional layer of usability that's built through the lit platform. So you might be able to auth in through a Web2 auth method like Google or Discord or Apple Passkey, and which is all set up within lit system. And if you want to do your own setup, we have more tutorials and tooling for you to set up your own relay server to do that. So programmable key pairs, they can be used to sign transactions on blockchains or state machines because the underlying algorithm is ECDSA for digital signatures. And we have a lot of different methods for creating wallets on EVM and Cosmos-based chains. And then for that conditional logic of programmable wallets, we have a concept that we call lit actions, which is the application logic that each programmable key pair should follow. This is useful for defining signing animations, handling auth, or generating conditional proofs, because the lit actions is where you might say only sign if these certain conditions are met, or only sign if this is true, or we have these auth methods. So you can check out these different use cases, as well as on the side here, we have different auth methods that are supported. We support address, lit actions, WebAuthn, Discord, Google, as well as one-time passwords. So one-time passwords are email or SMS login. We have that supported through Stitch. And then minting PKP, so minting a programmable key pair. You can go on our network chronicle and go and like get testnet tokens and then mint PKPs off chronicle. And then moving on from that, I'm going to go a little bit into claimable keys and what that is. So claimable keys is what we'll refer to as also HD keys, so homogeneous derived keys. And so when you're creating a new programmable key pair, it's now possible to deterministically derive keys, so the public portion of the key pair is known before creating the key. And these keys work off a set of root keys, which combined with the key identifier, allow the deterministic generation of new key pairs. Be sure to go here for the vocabulary around how to use claimable keys. So essentially, you might be able to, based on auth like email or something else, derive the public key for someone's email, and then when they're coming in, they can claim that account that's associated with their email. And so I want to go over a small, actually, demo here around using claimable keys. Okay, so I'm going to go over a short claimable keys demo. Mainly, this will be all on the terminal, and I will leave the building out the front end for you, but we're going to go through the process of creating a claimable key and then claiming it by looking up the programmable key pair and then linking our email through that auth. So, okay, first things first, where can you find this demo? Let's go on the search right now, where we can actually find it through the lit protocol repo here, or feasible. So we can find it here at the claim key, demo Node.js. I'll also link that within the ETHOnline kind of resources for lit. And so all the code is here. One thing that is noted is that you will need to create a Stitch account and get a project ID and a secret from that Stitch account. And then from there, you should be able to do the same exact demo that I'm doing. Okay, so jumping in, we have our Stitch project ID, secret, and then the lit relay API key. Be sure to follow or get. Oh my god, I can't talk today. So you can find the form on Lit's site to be able to request a relay API key. If not, feel free to jump on in Discord and ask about that. So there's some setup here. I'll go through a bit of the setup parts and then go through what's specifically around claimable keys and how to use that. So this first part, we're going to initialize the Stitch client and create the Stitch client. So you're just passing in your project ID and secret. And then from here, this is actually just taking in a prompt from that terminal command line where we're just asking for someone's email. So being able to pull in that email that we're going to associate that or create that claimable key for. And then once we have that email, we're actually going to call the Stitch login or create, which is actually just creating an auth for that. So we're passing in the email, and then that actually will prompt for that email, that'll prompt them to check their email for a code. So that's a one-time password code. That's what OTP here means, is one-time password. And so then we input that code to confirm, like, yes, I have access and authorization to this email. And then from that, we call the auth response, where we're getting the authentication response, where that method ID is that email ID we've received. And then the code itself is the one-time password code, which is, it is usually a string of numbers, of like 6 numbers. And then for the session duration, I think generally it's set to be 5 minutes. So someone has about 5 minutes to get that authentication code and pass that in. And then we have session response, which we call the Stitch client to get that session based on that user ID. And then as well as we get a session status. So the session status, we're actually calling Stitch's client to authenticate based on that auth response session token. So that's just the Stitch side setup that we'll need. And then on more of that lit side, we're going to jump into what we're building here, where we have the lit node client. And for this, we're doing strictly Node.js. So we want to import the lit node client Node.js. For other usage, you might just be importing the lit node client. And then we have the lit network, make sure that that is included in there, especially because we're using the v3 SDK. So then we connect our lit node client, which is essentially we're connecting to the lit nodes, and we want to wait for this connection to happen because that's how we'll be generating these lit specific parsers calling the lit nodes. And then from there, we initialize the lit auth client, which will help us actually generate a programmable key pair. So there we go back to our session, and we're calling Stitch in order to get a session, and we're passing the provider type, which I think in this case is the Stitch OTP, and then we have our user ID that we've generated from previously from that session status, and then the app ID, which is actually just the project ID that when we created that Stitch project. So from there, we call like auth method to get the auth method. And from here, that generally is like email is the auth method. So we're just passing in for the access token, that session JWT that we got in from session status. And then this line actually here, this public key. So this is actually where we are calling to get our public key, which is that public key generated from Lit's end in order when we're setting up claimable keys. And so session.compute public key from auth method, passing that auth method. And then from here, we have kind of 2 ways to cross-check that we've created the correct public key, as well as that public key once we've authorized in that is associated to that owner, so that email address. And so here, where we do the claim flag, we're actually saying like, okay, can I see that claim response for that public key to know that it has been generated? And the second one is a lookup, which is we want to see if, based on that public key, let's look up that programmable key pair and see that match that public key based on the email I'm passing in. So let's take a look at that. Let's start with the claim process. Email. I'm going to enter in my lit email here. Oops. Okay, sorry, that. My mistake. I missed out an M on there. Perfect. We'll go to my email. Okay, so then we have, from here, we have the lit compute key, local key, public key computed. Great. And then we can see from here the JWT body, that project ID, and then what time it started, what expiration, as well as the stitch endpoint, or what we call stitch, project ID. Okay. So then we're going to actually check our claiming, or let's check like if that PKP is matched up. I cut the screen really quickly. We're going to do a lookup here. We will have to authenticate in again on this lookup. And so this account I've been testing all day. So these are all just generated throughout the day as I've been testing it. And we could see we have many different public keys. And so from there, I would encourage you to test this on your own as well. And I would love to see folks building with claimable keys, especially there are a lot of different use cases that we've thought about at Lit, where you can kind of send wallets to people much more easily, especially folks who might not already have a wallet, or to be able to create different kinds of bundles with claimable keys. So yeah, excited to see what y'all build. And if you have any questions, please jump in Discord. We're active on Twitter as well. All of the links should be updated within the ETHOnline page. And I hope to see y'all out there hacking.